Block 3, Analytical Methods and Model, Unit 11, Condition-Based Maintenance, which is shortly known as CBM. So these are the objective of today's sessions. Student must understand the meaning and importance of condition-based maintenance. Student also understand the condition which should be certified for the implementing condition-based maintenance. Objective number 3, understand the benefit of using condition-based maintenance, especially reference to maintenance management in case of product-oriented organizations, whether it should belong to small scale, medium scale or large scale industries. Then objective number 4, understand the steps involved in implementing condition-based maintenance in various conditions. And the last objective of today's session is understand the scope and details of important condition monitoring techniques. So these are the objective of today's sessions. Let's introduce or let's move to the next part. The content of today's session basically includes introductions, then the overview of condition-based maintenance and condition monitoring. The next we have implementing condition-based maintenance, which basically includes selection of critical machines, then selection of prognostics, characteristics and condition monitoring techniques, setting alarm limit for prognostics, characteristics, preparing schedule for condition monitoring program. The next we have recording and processing of various form of data with reference to condition-based maintenance. Then establishing a schedule of maintenance job for implementing the condition-based maintenance. Moving to next ones, in case of condition-based maintenance, we have implementing various amount of method of condition monitoring. Under these methods, we have oil analysis, we have vibration analysis, we have motor circuit analysis, we have thermography analysis, we have ultrasonic monitoring should be there. Then we have radiography to identify various amount of cracks. Then laser interferometers. Then we have that is known as electrical monitoring analysis should be done. And the last we have electromagnetic measurements are there. So these are the content of today's sessions, especially reference to condition-based maintenance. Moving to next one. The next one we have the introduction parts. So before going to that particular topic of condition-based maintenance, first we have to understand that maintenance is defined as all the action taken during the operation stage of a machines to ensure that it will continue to function as per the expected standard or even better. So due to the implementation of maintenance to ensure the machines functions as per the expected standard by the organizations, that is why throughout the that is known as function of machines or equipment, we have to take care about those activities which basically made large amount of failures or breakdowns. So it also encompasses those functions which prevent the machines to lose any of its functionalities. In other words, we are basically prevent failures so that we can avoid any kind of error due to the unfunctionality of machines. So that is why the condition-based maintenance is implemented. They are basically focus upon time-based preventive maintenance by monitoring the condition of equipment, ensuring the maintenance just when it is needed or required. So this is the step where many companies are basically implement condition-based maintenance so that they can easily apply time-based preventive maintenance by implementing various monitoring the condition of the equipment. So if required, they must replace, or if required, they must go for adjust, and they will also increase the expected standard, or even better in case of functionalities. So let's understand what are the different condition-based workflow are there. So if you install various amount of sensors, the next important part is establish a baseline for condition-based maintenance workflows. Then start monitoring and collect various form of data. Then identify the anomalies in asset data. Then create the work order. And depending upon the work order, you have to go for perform the maintenance works. So this is the standard form of that is known as workflow of condition-based maintenance, which is applied inside the organizations. So as I told, that is basically consists of 5 number of steps. The first steps we have install sensors. establish a baseline for machines or equipments. Then through the sensor, you have to start the monitoring and collecting various form of data. Then after that, you have to go for that is asset data, which is vastly used to create the work order. So after work order is generated, then you have to perform the maintenance work. Moving to next important part, as far as concerned with the condition-based maintenance, that can be treated as the method used to reduce the uncertainties. Nobody can simply reply that what is the durability of machine or what is the durability of equipment. So due to the uncertainty of maintenance activities, it is carried out according to the requirement of indicated by the equipment conditions. For example, you are using a bearing plug or using a spark plug in case of two-wheelers. So their equipment condition is different in different environments. So that is why, especially in reference to condition-based maintenance, you are implementing various kind of maintenance strategies. So one of the famous strategies that is known as condition-based maintenance, and under the maintenance you have to provide that is known as ensure the machine's functions to improve the expected standard as well as the even better that can be performed to achieve higher side of productivity or enhance the quality of product as expected by the management of the companies. So if you go to the fundamental of maintenance strategies, one of the most important strategy I have already told that is known as condition-based maintenance. So whenever you go for breakdown the maintenance strategy, we have breakdown or corrective maintenance. The next we have preventive maintenance, and we have total and productive maintenance again. So under preventive maintenance, many companies are basically use time-based maintenance, but those who are upgraded in their technologies, in their processes, they simply implement the condition-based maintenance. So let's understand the fundamental aspect of condition-based maintenance. So in case of condition-based maintenance, if you goes to point number one, it is a maintenance techniques that involve monitoring the machine conditions and predicting the machine failures. For example, we have several factors are there. One of the major factors that is known as machine vibrations, or due to high run in case of temperature should be rise, and machine cannot be resist excess amount of pressures, and due to the leakage in case of oil, or that machine also produce large amount of noises. So these are the environmental conditions with reference to the vibration, temperature, pressure, oil or noises. The machine may be failed. So due to the vibrations, temperature, pressure, oil and noises, that is why to predict the machine failure before the actual or real breakdowns, they are basically establish this kind of techniques to identify so that they can eliminate the machines or provide the adequate maintenance so that the functionality of machine should be go for expected levels. So point number two, the condition-based maintenance rely upon actual machine health to dictate when and what maintenance is required. So for example, huge amount of vibration should be observed in case of bearing blocks. So that means you have to replace the bearing so that smooth operation of transmission or power transmission should be proceed from one workstation to other workstations. Similarly, if you observe the temperature is rise, in that cases you have to go for detect and identify the source of temperature where it should be affect the machines or equipments. Similarly, in case of pressure equipments, in that cases you have to maintain the indicators of pressures, especially reference to the safeties, so that you can avoid any kind of casualty happening inside the organizations. And the next important part is noise. So in that cases, you have to check the oil level as well as the different parameter which is basically generate the noise or maybe sound in case of machine or equipments. So in the simple word, if you go for condition-based maintenance, as a direction of maintenance action based on the indications of asset health or machine health, as determined from the non-invasive measurement of the operation and condition indicators. So these are the conditions I have already given, that is known as vibrations, temperature, pressure, oil or noise. Then point number four, the CBM allows the preventive and corrective actions, as we have discussed in the previous or introduction slide, that condition-based maintenance is a technique or it is a strategy which is basically applied under the preventive maintenance. So in that cases, you have to optimize and avoiding the traditional calendar which is applied inside the companies and run the based maintenance strategy in the form of condition-based maintenance. That means if you go for the traditional calendars, they have done the maintenance work on day-to-day basis or maybe weekly basis. On some cases, they go for monthly basis or they go for quarterly basis. If required, they go for shutdown. So depending upon the shutdown, it directly affects the entire productivities. So that is why to reduce that particular actions, you have to optimize the traditional calendar so that you can easily implement the condition-based monitoring by assigning various amount of sensors and various amount of analyze tool to collect the form of asset data. The last important point, the condition-based maintenance is based upon the condition monitoring. That is why large amount of sensor are installed, whether it should be the pressure sensor, vibration sensor, or maybe the temperature sensors, which provide the different asset of data in the form of the known machine failures or in case of the known failure to be occurred, so that you can eliminate the process or eliminate the machine or equipment. The smooth flow of material should be passed from one end to other end. So this is the overview of condition-based monitoring. Moving to next one. The next one we have condition monitoring. So as far as concerned with the condition monitoring, first the entire machines has installed with large amount of sensor networks. So if you observe the images, we have local EMHI are there, we have sensor data processing are there, and sensor interface are there, we have industrial standard sensors are there, we have wireless sensors are there, and we have wireless gateways is there. So these are basically provide large amount of data in case of monitoring the machines. So starting from the sensor interface, then industrial standard sensors, then wireless sensors, then vision and sound through the CCTV surveillance, you can easily monitor the machine conditions. So these sensor interface data, the industrial standard sensor data, the wireless sensor data, the vision and sound data are directly go to the sensor data processing, and which is attached to the local HMIs. Through this one, it should be directly goes to the cloud service or the local servers. And the local server is basically connected to the condition monitoring dashboards. So whenever that is known as maintenance manager is want to go for condition monitoring of a specific machines, they can identify the various analysis. The first one we have vibrations, then temperatures, then noise, then oil leakage, or any kind of that is known as sound will be occurred from the machines. So this is the overview of your condition monitoring. If you go for the theoretical aspect of condition monitoring, it is the monitoring of operational plants, analysis of data, obtained to detect incipient fault and predict the residual life for the safe operations. So that is why nowadays, especially reference to Industry 4.0, many companies are vastly use this monitoring or condition monitoring system in their existing system to identify the various amount of fault, especially reference to the safe operation with reference to production. So in case of condition monitoring fall into two distinct classes. The first one we have monitoring which can be carried out without interruptions to the operation of the equipment. That is online monitoring. Through the CCTV surveillance you have go for online monitoring. This is the best example for condition monitoring. The next one is monitoring which requires shutdowns of unit or release it from its prime duties. That is of offline monitoring. So if the condition of the machines or equipment is very critical, in that cases it requires shutdowns, or if required it's go for offline monitoring. So these are the two basically distinct classes of condition monitoring. Moving to next ones, implementing the condition-based monitoring in our organizations. So for implementing the condition-based maintenance in a typical industries are called for a few steps which are below. So let's understand what are the different steps which is include in case of implementing the CBM based maintenance. The first one is selection of critical machines on which the condition monitoring has to be carried out. This is the first steps. Then second step we have selection of appropriate prognostics characteristics and setting its limits. Then third one is selection of appropriate measurement tools or condition monitoring method for each critical machines. Then next we have prepared the schedule of condition monitoring program and collect the various form of data which is known as asset data. Then recording and processing data including trend analysis. And the last, if required, we go for repair, or if the critical condition of machine is surpassed the expected level, in that case go for replacement and other type of maintenance activities based on the condition of the machines. So if you require to go for adjustment, or if you go for that is known as major or minor repair, or the condition of the machine is very critical, in that cases we will go for that is known as replacements. So these 6 number of steps are basically implemented in case of implementing the CBM or condition based maintenance inside the organizations. The next is selection of critical machine. How we have identified the criticality of a machines. So first important part is those failure may cause loss of productions. For example, in a power plant or in a captive power plant, the boiler is a major component which is involved in case of power generations. So first you have to take care about the boiler, which basically provide the steams to the turbine which is connected to generator, which basically provide the power. Similarly, if you take the cases of that is known as ceiling fan in domestic applications or maybe commercial applications, the most critical part that is known as the coils. So first you have to identify these kind of that is known as critical machines and go for which basically provide the loss of production. The next important part is unacceptable qualities. So due to the engagement of large number of workstations and their productivity is not up to the mark, in that cases they basically provide the that is known as quality defects, or it may be defects of product which may be loss of productions. So you have to identify those kind of machines who provide unacceptable quality of product or the causes of safety hazard to personals. So these 3 things should be observed in case of machine or critical machines. The first one is loss of productions. So due to that machine, company faces loss of productions, unacceptable qualities, and cause higher side of safety hazards. The next important part is this is precisely the reason why this is important. Select only the machine as the first step. So this is the first step, which basically includes these factors for a critical machines. Then following guidelines are found useful in identifying the critical machine in a plant. The first important part is part of a continuous process, then parts of a single production lines, then equipment without standbys, then part of a production line without, that means with inadequate intermediate storage capacities, then part of a line transforming dangerous fluids, the machine operated high temperatures, high pressures or high voltage, the machine containing high inertia, high speed components, machine arranged in very compact layout with high maintenance cost. So these are the following criteria found in case of identify the critical machines. So I repeat, the first one is part of a continuous process, the second one is part of a single production line, the third equipments without standbys, the next is part of a production line without intermediate storage capacities, and the next one we have part of a line fluids, then machine operated high temperature, pressure or voltage, and the last one is machine containing high inertia, high speed components, the machine arranged in very compact layout with high maintenance cost. So these are the basically applied in case of selection of critical machines. Moving to next one. The next one we have selection of critical machines. Here we are basically divided into 3 categories. The first one is critical machineries, then essential machineries and non-critical machineries. So before understanding this particular offset, first you have to understand how they have implemented the selection of critical machines and what are the different conditions solutions need to be applied to that particular equipment. So if you go for the critical index of a system, it is often used to determine the type of condition monitoring solution that need to be applied to your equipment. So criticalities index therefore divided into 3 categories. As I told, the first one is critical machineries, the second one is essential machineries, the third one is non-critical machineries. So let's take an example of earth moving equipments. So in case of earth moving equipment, this is or maybe the crane or movable crane is highly critical equipments. Most of the parts are highly critical. Similarly, if you go for known as concrete mixers trucks, so these are basically provide critical equipments. So in case of low impact, moderate critical equipments are there. For example, loaders are there. And in case of no impact, you can take the example of that is known as forklift trucks, which is used inside the companies. So these are the different that is asset criticality class. But if you go for theoretical point of view, let's understand the first category that is known as critical machineries. This type of machinery has the highest HREL level within the production chains. It includes equipment such as power plants, steam boilers that are the core of the operation and need very high or tight conditions monitoring systems. So these are very, that is known as power plant, which consists of turbine. That means these are the pressure vessels. In that cases, huge amount of condition or tight condition monitoring should be there. So second categories we have, that is known as essential machineries. So in case of essential machineries, these are the integral part of the production chain. However, in case of unexpected failures, like production will not be affected as the process continues. Monitoring the condition of these machines, if is vital to implement the alternative plan at the right moments. So in case of essential, these are applied to the production plant. But the thing is that when the condition of this machine is vital, in that cases, you have to provide the maintenance work and go for the alternative plan at the right moments. The last one is non-critical machineries. These machinery have a minor impact on the productions and do not usually represent an economic risk for the production chain. So condition monitoring of these machine is considered of low criticalities, and portable system is undoubtedly a good solution for this particular selection of critical machines. So these are the different three number of criteria of selection of machines. The next we have that is known as selection of prognostics, characteristics and condition monitoring. So first important thing is that how critical machines are selected. The next step is condition based maintenance is selected for the prognostics characteristics, that is the parameter is associated with the maintenance machines to measure and monitor. So there are several parameters such as vibration, as I told. Then in case of actuating machines like hydraulic machines, temperatures, presence of wear and debris in the lubricants. These are basically provide the prognostic characteristics, especially reference to condition monitoring techniques. So let's understand by selecting the particular characteristics of a few questions are must be asked. So what are the questions? The first question is how easy or difficult is to measure the parameters. So in case of vibration should be basically done, or temperature should be may be measured. The next is what kind of instrument or sensor is required and what are their basically availability as well as the cost. This is the second question is asked. Then third question is are there method available to protect the trend of deteriorations and decide when the maintenance has to be taken. So these three questions must be asked whenever you go for selection of particular characteristics with reference to the prognostics characteristics. So let's understand the significance of if the risk priority number, that is RPN, is exceed a predetermined value in case of particular scale. The risk priority number, or which is shortly known as RPN, is mathematically expressed as Fi into Fc into FDP. So Fi stand for your failure intensities, Fc stand for failure criticalities, and FDP is the fault detection probabilities. So the value of Fi, Fc and FDP could be fixed on the scale of 10. So for calculating that is known as different aspect of your risk numbers with reference to the significance of components, this value should be calculated. So moving to next one, the next one is condition monitoring techniques. So before going to the ideal condition monitoring techniques, which have following attributes. So let's take an example of fan motors. What are the different parameters should be basically monitored under the condition based monitoring? The first one is current motors. The next is in case of fan motor, we go for lubricant oil conditions. Then if required, we go for thermographic analysis. Then must go for the identify or analyze the pressures. Then motor vibration should be done. Then online parameters should be checked. In case of it is known as temperature should be tested. And finally, you have to go for the performance monitoring to run in case of 5 hours or maybe more than 10 hours or maybe 30 hours. So these are the conditions to be monitored in case of the under the condition monitoring techniques. So before implementing those things, you have to consider following attributes. And what are the attributes? Let's understand. The first one is simplicity in the use with pass-fail indication on a simple scales. So simplicity means whether you go implementing the condition monitoring techniques is pass or fail, that indication should be measured depending upon the that is RP and scales from the 10 number. The next is insensitivity to sensor locations so that repeatability is not lost by the careless technicians. So you have to take care of the sensor location so that they can easily take large set of data, and they are also implementing some condition monitoring techniques. The third one, we have insensitivities to the load condition of the machine so that the measurement are not maintenance audit omitted because of inconvenience. So this precludes offload monitoring techniques unless regular offload periods are programmed. So you can go for that is known as taking the load conditions in case of offload as well as onload or regular loads of the program, which is basically taken in the significance of condition monitoring applied to the machines or equipments. The next is robust equipments to withstand the type of maltreatments common in industrial situations. For example, instruments to withstand droppings, cables withstand waters, oil and heavy goods. These are the different examples which is basically provide robust equipment withstands the type of that is known as maltreatment common in case of industrial applications. The intrinsically safe techniques in both the technical sense and manner of use, the safety procedure can be go down the monitoring program in great depth. So that is why if you involve in a particular manufacturing organization, especially in reference to maintenance management, they provide the safety procedures. When an operators or a technician is involved, they can easily identify what are the safety measures and how to operate the machines, how to set up the machines before implementing the condition monitoring for several parameters. Moving to next one. The next one is setting the alarm limit for prognostics characteristics. So for every parameter being monitored, like vibration, temperature, wear debris, then oil conditions, maybe pressures, at a maximum limit to be decided, and taking into account perform the required from the particular components. So whenever you implementing or setting the alarm for prognostic characteristics, you have to take care about the vibrations, noise, temperature, wear debris, or maybe pressure at a maximum limit so that you can easily perform the requirement particularly for the component condition monitoring. So this could be done by using information from several sources. What are the sources? First source we have the national or international standard. The next source we have diagnostics equipment manufacturers, those who are basically supply or that is known as manufacturing the machine and supply to a number of companies. The next is equipment manufacturer also. In case of manufacturers of number of machine and equipments, there also includes. And the last one is experience on a similar machines. The operators are basically experienced on the similar machine, or number of that companies are also specialized in case of similar machines. So they are basically provide different amount of information for condition monitoring. So let's understand from one by one. So first important aspect of that, if you go for the preparing the schedule for condition monitoring program, in the first steps you have to go for that is known as plan and schedule of condition monitoring program. Then specify the component to be monitored, which component may be critical due to the index of criticalities. Then location of measurement should be taken, and the method and methodology of monitoring. These are also includes, especially reference to periodicities of monitoring is also involved. So these are the factors basically considered for fixing of the periodicities of the making the measurements. So how the periodicity of making the measurement should be done, especially reference to condition monitoring program. The first important part is criticality of the equipments. So the criticality of equipment should be involved the following step or initial step. That means if the machines is provide loss of productions or unexpected qualities, or maybe that is known as it also provide the safety hazard. These are basically under the criticalities of the equipments. The next one is availability of standby equipments. So if you identify this criticality of equipments, especially reference to the criticality index, in that cases you have to go for the standby equipment so that they should not hamper the production activities. The next important part is operating conditions. So in case of operating condition, you have to focus upon the different parameter. That means you have to measure a parameter like vibrations, temperatures, oil pressures. The next important part is the temperature is also considered in case of operating condition. The next one is cost of making a check, then cost of breakdown repair, cost of preventive maintenance, then cost of downtime, then total cost of maintenance is also included. So the objective of total maintenance must be reduced, and mean time between failure and mean time between repair. That means availability and reliability should be considered. And the last important part, you have to take care of the personal safety levels whenever you prepare the schedule of condition monitoring program inside your organization. So I repeat, whenever you start these programs, you have to plan and schedule the condition monitoring programs, then specify the component to be monitored, location of measurements, methodology of monitoring, and periodicity of the monitoring should be considered. And these are the factors should be considered, starting from the criticality of equipment. The next is availability of standby equipments, operating conditions, then cost of making a check, then cost of breakdown repair, then cost of preventive maintenance, then cost of downtime, and total cost of maintenance. And the last one is reliability, that means maintenance time between failures and mean time between repair. Reliabilities and availability should be there. And the last important part is personal safety. So moving to next one. The next one is recording and processing of data. So whenever you implement the condition-based monitoring inside your organization, that means you are setting up an information system or IT system to meet the basic requirement. That means what are the basic requirements we have? Collecting and processing of large quantity of informations not previously available. The second one is regarding the condition of each part of a machine. So for example, if you take the cases of your own bicycles, in that cases, there are several components are associated with the bikes. The first one is engine, the next is the chassis part, the next important part is the front wheel, the rear wheels, the drive shaft, the drive systems. The next important part is the electronic devices. These are basically the different parts of a particular bike. So similarly, in the same cases, inside the organization, they must go for collecting large amount of processing of information, the data which is not previously available. The next important part is regarding the condition of each part of the machine. Then point number 2, initiate the corrective maintenance actions within the lead time. That means the period of the time of limits, conditions, and the emergency shutdowns. So after that one, in this respect, there are two different situations may be examined by the encounters. The first situation or first condition is that the condition of machine is not yet close to breakdowns. In this case, the normal procedure through the maintenance planning section will be followed. And the second one is the condition of the machine is already well within the lead times. That means it is near to breakdown. In these situations, the information must be directly passed on to the maintenance supervision for carrying out emergency corrective maintenance. So these two situations should be encountered. I repeat, the first one is the condition of machine is not yet to close breakdowns. So in that cases, the normal procedure through the maintenance planning section will be followed. Whether they go for that is known as corrective action, whether they go for preventive action, or whether they go for predictive, that is known as maintenance. But if you go to the second conditions, the machine is already well within the lead times. That means it is near to the breakdown. And in this situation, the information must be directly passed on to the maintenance supervisions for carry out the emergency corrective maintenance so that there should not be hampered to the entire production activities. So moving to next one, the next one is establishing a schedule of maintenance job. So what are the points should be considered under this particular schedule of maintenance job? Under condition-based maintenance, the examinations team supplies the engineers with all the information concerning the condition of the machines, while other staffs supports him with necessary information. So most of the cases, the condition-based engineers is basically assigned and all the information is directly supplied them, and the staffs are basically support with the necessary information. This is the step number 1. The second step is that maintenance is carried out before the failure occurs. So the main objective is to decrease the number of failure as much as possible and carry out the maintenance only when it is necessary. So this is the second objective. Then third one is the maintenance engineer takes the decisions and coordinates the maintenance teams on the basic data and become the true manager of the departments. So Most of the cases, the maintenance manager or engineers are under the middle level of management. So they take the important decisions with respect to coordinate the maintenance teams on the basis of data, and they become the true manager for the department for elimination of large amount of error from the system, so that the necessary maintenance work should be carried out. And the last one is the structure of maintenance department because become more flexible. So there should not be any barrier between the top to bottom levels. If they communicate, the communication should be very clear. If they instruct, the instruction should be very clear from the top to bottom. And if required feedback, the feedback also collected from the top to middle and middle to bottom. And that should be informed to the top level of management. So that is known as flexibility should be there. In that cases, they will maximize the that is known as maintenance work when it is needed in case of that is known as production department. Moving to next one, the method of condition monitoring. So this is most important aspect of condition monitoring, and these are the basic inspections done in case of various level of industries. As I told in the beginning of this sessions, whether it should be applied to small scale of industries, large scale of industry, or maybe medium scale of industries. So small changes like abnormal heat or pressure, strange sound, excessive vibrations, or a different smells are often sign that something is going highwards. So however, the condition monitoring techniques vary from the simplest inspection to the cutting edge technologies. So here 9 types of condition monitoring has given. We will discuss one by one. So let's understand what are the different condition monitoring which is applied in case of industries. The first one is oil analysis. The second one is vibration analysis. The third one is motor circuit analysis. The fourth one we have thermographic analysis. The fifth one we have ultrasonic monitoring. The sixth one we have radiography analysis. The seventh one we have laser interferometers analysis. The next is we have electrical monitoring systems, and the last one we have is electromagnetic measurement systems are basically applied for condition monitoring. So as we have already discussed about the small changes, that means adjustment or like abnormal heat is generated or abnormal pressure is generated from the machines or maybe the equipment, or maybe the strange sound or excessive vibrations. So these are the different signs of that is known as the condition monitoring, which is need to be repaired so that we can enhance the productivity as well as enhance the quality of product inside the organizations. So let's understand what are the different type of condition monitorings. We have the first one is oil analysis. So in case of oil analysis, it is applied to machine oils, lubricants and fluids. So if you take the cases of gearboxes, engines or pumps, they require that is known as machine oil and lubricant and fuels and fluids. So it can detect the wear and overheatings and contaminations. So in case of contaminations, high level of iron, for example, often indicate the dart and grit, and spotted on the time. This reduces the gearbox failure by 50% and avoiding the contamination of decreased bearing failures by 75%. So here are the some example of ferrography tests. So if you observe, the slides are given and the magnets is basically placed. The large particles are deployed at the entry point where the magnet pull the weakest, and smaller particles are directly deployed along the slide as the magnetic pull the strength. So depending upon the ferromagnetic test, it can reduce the contamination of ferrous in case of oil, which is basically arise due to the bearing failures. So whenever you go for oil analysis by that is known as inspections, or that is known as they are also providing the large amount of indication by the routine inspection done by the maintenance department. And if you find the contamination of ferrous, in that cases you can decrease the failure life by 75%. And if you reduce the gearboxes failures, regularly top off through the lubricants, machine oil and fluid, so automatically there should not be any breakdown to happen to that particular gearboxes. So there are several oil analysis method available for preventing these kind of failures. So one of the famous was ferrographic tests, where water presence tests are also conducted, viscosity tests are also conducted, ICP on spectroscopic tests should be done, dielectricity strength Test should be done. Microbial analysis, iron content, especially reference to particular quantification index, infrared spectroscopies, ultraviolet spectroscopies, potentiometrics titerations, total acid number, or to identify the total acid number or total base number. These are the few that is known as famous method is basically applied to identify the contaminations as well as the spotted various amount of failure in case of gearboxes. So that is why the initial step you have to go for checking the oil on the routine basis so that you can easily avoid that is known as the contaminations as well as the spottage, reduce the gear failures in case of number of gearboxes or those equipments which are vastly used lubricant fluids as well as oils. So moving to next one, the next one is vibration analysis. So if you go for vibration analysis, one of the most well-known predictive maintenance method, it can be detected the misalignment, imbalance, wear out 3 months before they cause the breakdowns. So let's take an example of vibration analysis, which is basically done in case of vibration aptitudes and versus frequency of circulating parts or machines. So through this graphical presentation, you can easily identify the average vibration levels of gearbox to motor and motor to gearbox. So most of the cases vibration is happen due to the that is known as misalignment in case of that is known as connecting shaft or maybe couples. Properly imbalance of that is known as coupling shafts, and due to the imbalance of coupling shaft, large amount of wear out should be observed. And the wear out, if you detected previously, in that cases, it should be easily eliminated the number of breakdowns. So it is also an opportunity to improve the energy consumption since the misalignment of water pump, for example, spend 15% more energy. So that is why it's the duty of that is known as maintenance managers. They must go for precise alignment of water pump so that they can easily reduce the percentage of energy consumptions. So moving to next one, the vibration monitoring is based upon the concept that provide operating condition has not been changed. In an increase in vibration, it is indication of impending failures. So whenever the vibration is rapidly rise, in that cases the failure must be occurs. So greater increase in vibration levels, greater the deteriorations. So machine may be damaged. Machine also provide large amount of cracks during the shaft as well as the upper part of the motor as well as pump. So for monitoring the vibration systems, the following three are: first one is you must go for periodic manual monitorings. Automatic surveillance should be there through the CCTV. You can easily through the installation of CCTV surveillance, you can easily identify the imbalance as well as misalignment of various gearboxes versus motors. And the last one is continuous monitoring systems. So through the initiation of both that is known as CCTV surveillance as well as sensor, you can easily identify the different graph levels of vibration amplitude versus the frequencies. So this is all about the vibration analysis. Moving to next one. The next one is motor circuit analysis. So in case of motor circuit analysis, is also known as shortly known as MCA testings. It assesses the condition of electric motors. So it can be used to analyze the motor condition, including the rotors. The next we have coupling belt problems, the power qualities, electric imbalance, and the last one is insulation. So if there is leakage in case of insulation, they also increase the consumption of electricity. So to provide the preventive failures, the motor circuit analysis can be used to cut the energy cost and improve the equipment efficiency by 10 to 15%. So that is why many companies are conducting motor circuit analysis to increase the life of various motors with reference to the number of components like rotors, coupling belts, power qualities, electric imbalance, and the last one is insulations. The next we have that is known as thermographic analysis. So in case of thermographic analysis, they are basically study the heat and radiation pattern of the machines due to overrun. In that cases, they will go for the known as simulation analysis of the outer casing of various component. Due to high run, what is the heat and radiation pattern of that particular machines. So they are also using various amount of that is known as wide application, including detecting the misalignments, or you can simply pronounce as due to misalignment of various that is known as coupling imbalances, improper lubrications, then wear and stress in mechanical parts, These are basically provide large amount of heat and radiations pattern in the machines. Or if you goes for electrical equipments, it identify overheatings, pipe leakage, pressure vessel weaknesses. Infrared thermography in a particular has become more popular method for preventive maintenance and non-destructive testings. So if you observe this thermographic analysis of a electric motors due to overrun and misbalance or imbalance of that is known as coupling shaft from motor to gearboxes, in the outer casing provide red color that is known as it is highly heated areas, and the blue color is low heated area. So blue color do not provide any kind of impact on the motor, but the red color is basically provide the high heat and radiation pattern of the motors. So by applying the thermographic that is known as analysis, one can easily understand, and they must go for that is known as a higher set of safety standards to prevent these kind of that is known as wear out of machines and breakdown of machines, so that the effective of removing safety reducing or danger point should be reducing or failure causes should be reduced by 90%. So if you go for the summary of thermographic analysis to reduce the risks, prevent failures, decrease the cost and losses in case of machine and equipments. Moving to next one, the next one we have ultrasonic monitoring system. So in case of ultrasonic monitoring system, if you observe the first figures, the motor is connected to number of that is known as data readers, that is known as data collectors. Then data that is known as your web or clouds, and it is well connected to the desktops, which provide the different graphs with reference to ultrasonic monitoring. So this ultrasonic monitoring is basically applied for vibrational analysis techniques. So in case of ultrasonic monitoring, use high frequency sound wave to catch the leakage, part leakage, cavitations, which reduce the inspection by 30%. So in case of ultrasonic is specially cost effective when it is applied together with the vibration analysis. That means you are using large amount of sensors which are basically capture both things like vibration as well as the ultrasonic monitoring, and infrared thermography is also used. So airborne and structural borne ultrasound is gaining traction as a good option to detect the stress wave on the rotating machinery. So if you observe the second one, a pump should be done ultrasonic monitoring to identify the leakage and detect, so that you can reduce the inspection by 30%. So these are basically huge large scale industries which have infinite number of machines and machines tools are there or equipments are there. The next we have that is known as radiographics. So including radiographic analysis and neutrographics is very thorough method for non-destructive testings. So if you observe this once, this radiographic machines are basically assigned to detect the leakage in case of welding join of different pipe. So by implementing these things, you can easily identify the leakage in case of weldings, and simply the micro leakage as well as damp or maybe that is known as crack should be easily identified through the radiographic analysis. So most of the cases, imaging allow technicians, or this radiographic images allow the technician to inspect the internal defect such as corrosions, is inserted parts, flaw in weldings. However, the main advantage is that it can be used in all type of material, provided the technician protect themselves, because radiographics radiations are very harmful for human being. So proper safety should be used whenever you conduct the radiographic analysis for any kind of machine equipment, and it is vastly used in case of that is known as pipeline industry or plumbing industries, especially reference to metal plumbings and that is known as non-ferrous metal plumbing areas. Moving to next one. The next one is laser interferometries or laser interferometries analysis. So in case of laser interferometers, measures change to calculate the displacement based upon the laser generated wavelength. So if you go to this laser interferometers, so a laser beam should be accessed towards to generate the wavelength by the help of beam splitters, and camera is capturing the entire data. So with reference to the surface and the test surface, number of data are collected and these data are properly analyzed. So what kind of data are basically generated? To identify the surface defects and subsurface defects like corrosions and cavities. The interferometers includes laser, that is known as serographics, laser ultrasonics, strain mappings, electronic sparkle patterns, interferometers, and digital holography should be done. So these are vastly used in case of that is known as industrial application like joining of various parts and components. The next is welding of various components, brazing of various components are basically used under the laser interferometries analysis. The next one we have that is known as electrical monitoring systems. So electricity is the one of the biggest reason behind the injuries and fatalities in work conditions. And preventing the electric failure with close monitoring is not avoid breakdown but improve safety. So this includes the test of SS resistance, induction, capacitance, pulse response, frequency response, and degradations. So in that cases, the electrical monitoring conditions techniques include megoharmometers testings, high potential or dielectric resistance test. That is, the example is to determine if the insulation is good conditions. Then power signature analysis to test the current and voltage. Then battery impedance testings, surge report testings which detect the insulation flaws, and in some extent it go for motor circuit analysis too. So if you observe in case of electrical monitoring, a special device is generated which is connected to the desktops, and they are basically monitoring the different aspects like induction, capacitance, pulse response, resistance, frequency response, and degradations of various electrical components. So which improve higher side of the known as safety inside the organizations because most of the parts are used large amount of the electricity to run and to the known as perform various amount of activities in case of production process. Moving to next one, the next one we have electromagnetic monitoring. So first we have to identify the electromagnetic spectrums. So if you observe in case of electromagnetic field, the lowest field is provided by static electric and magnetic field by that is known as your magnets, and highest radioactivity source is generated by that is known as radioactive sources are generated higher. The second one is X-ray, the third one is ultraviolet, then fourth one is visible sunlight, fifth one we have microwave links and radars. Then your smartphone is also generate radio frequencies. Then TV and radio broadcast is also providing radio frequencies. And the last one is that is alternative electrics and magnetic fields like towers and your even your electric diodes are basically provide the electromagnetic spectrums. So which electromagnetic spectrum are harmful? So for example, starting from the magnet to up to your microwave, links and radar, they are non-agent. These are little bit that is known as non-harmful for human body. But if you go for ionized electromagnetic spectrum, starting from visible sunlight, ultraviolet, X-ray, radioactive sources, these are very harmful for human bodies. So let's take an example of the radioactive sources. In that case, it should be directly goes to the your DNA and DNA to the next generations, and huge amount of joint bones problems as well as DNA that is known as fault should be observed in the next generations. So to identify as well as to eliminate these kind of electromagnetic spectrums, the electromagnetic measurement are basically applied for identify the magnetic field distortions to spot crack, dent, corrosions, weaknesses, and other defects. Perhaps the most prominent method of electromagnetic condition monitoring is eddy current testing, or which is shortly known as ECT, which is used in case of petrochemical industry to detect the tight cracks. The second one is the electromagnetic monitoring techniques such as pulse eddy currents, remote and near field eddy current. The next is saturated low frequency eddy currents testing, eddy current arrays, magnetic particle inspections, magnetic flux leakage, metal magnetic memories. These techniques seem specially fit for the non-ferrous materials and conductive material like tubes, condenser, boiler, and aircraft surfaces. So, in the year that is known as Skelly and Harris, 1978, suggests the common method for condition monitoring under two categories. The first one is online monitoring method, which include visuals, arrival, tactical inspection of accessible component, The next one is temperature monitoring, lubricant monitoring, leakage detection, vibration monitoring, noise and noise monitoring, and the last one is corrosion monitoring. So these are the first categories. In the second one, in case of offline monitoring, which may include visuals, aerial, practical inspection of accessible component, crack detections, leakage detections, and corrosion that is known as monitoring to be done in case of offline. So, as far as concerned with the electromagnetic spectrum, first you have to understand which that is known as machines or equipments are providing high that is known as frequencies. So I have already given the example of that is known as magnet, then the electric towers, then your dryers, then televisions, then mobiles, the microwaves which is using this radar. These are under the category of non-ionized electromagnetic spectrum. But in case of ionized electromagnetic spectrums, we have visible sunlight, ultraviolet rays are there, X-ray ray are basically used, and the last one is most harmful, that is known as radioactive sources, which provide large amount of electromagnetic field. So that should be basically used to identify the various amount of cracks. The next important part is that is known as weaknesses, other defect like thickening defects, then corrosions, and spot the various amount of cracks in the machinery equipments. So let's review the entire sessions. So in this particular session, we are going to discuss about that is known as condition-based monitoring. First important part we have discussed, that is known as condition-based monitoring. So here 5 number of steps are basically used. That means install sensor, establish the baseline for monitoring, then start monitoring, collect the data, then identify the anomalies in the asset data, then create work order. The last one is perform the maintenance. So most of the cases, many companies are vastly use this condition-based monitoring, especially increase the production and reduce the breakdowns. So in case of condition-based monitoring, they are basically involve the monitoring machine conditions, which are includes vibrations, temperatures, pressures, oil, and noises. The condition-based monitoring basically focus upon the health, which detect when the maintenance of health of the machines, which detected when and what maintenance is basically required. So the moving to next one. The next one is condition monitoring. So condition monitoring is fall in the 2 distinct classes. Monitoring which can be carried out without interruption of the operations of the equipments, that is known as online monitoring. And the second one is that is known as offline monitoring. That means monitoring which requires shutdowns of the units or release it from its primary duties. So in that cases, a large set of sensors which is connected to the edge computing, and edge computing is connected to your cloud services, and cloud services is basically connected to the condition monitoring dashboard for data analytics. So moving to next one. So these are the steps which is basically used for implementing the condition-based maintenance. That means selection of critical machines on which the condition monitoring has been carried out. The next step we have selection of appropriate prognostic characteristics. That means setting its limits. The third one we have that is known as selection of appropriate measurement tools or condition monitoring method for each critical machines. The fourth one we have prepare schedule of condition monitoring program and collection of data. The fifth one we have recording and processing data including trend analysis. And the last one we have go for replacement, replay, repair and other type of maintenance activities based on the condition of machines. The next important part we have identify the critical machines by implementing the useful identify critical machine in a particular plant. So here we are basically use the steps. First step is loss of productions, unacceptable qualities, cause of safety hazard to the personnel. These are the primary steps. But if you go for wide, that is known as guideline for identify the critical machines in a particular plant, you have to go for the first one is part of continuous process, part of signal production lines, equipment without standby, part of production line without that is known as storage space. The next is part of line transforming dangerous fluids, the machine operated at high speed, high temperatures or voltage, machine containing high inertia, high speed component, and the last one we have machine arranged in very compact layout with high maintenance cost. So these are the basic criteria which is applicable for selection of critical machines. Moving to next ones, the next we have that is known as criticality index we have. So these are classified into three types. First one is critical machineries, which have highest HRE level within the production chains, and without this machine, you cannot that is run the that is known as operations. The next one we have essential machineries. That means it is an integral part of productions, but you have to go for alternative plan for the right moment whenever it is under the breakdown. And the third one is it is non-critically machinery. That means you have to provide a condition monitoring at lower criticalities to go for a portable system or on up doubtful good solutions. The next we have that is known as selection of that is known as condition monitoring techniques. So here three questions are basically asked: how easy or difficult is to measure the parameter? The second one is what kind of instrument or sensor is required? What are their availability as well as the cost? Third important question is asked: there are methods available to project the trend of deteriorations and decide on when maintenance has to be taken. So for this, you have to go for component significant, which is related to risk priorities, and it is shortly known as RPM. So the formula for or mathematical expression for RPM that equals to Fi into Fc into FDP. So Fi stands for that is known as failure intensities, Fc stands for failure criticalities, and FDP stands for fault detection probabilities. So value of Fi, Fc and FDP could be fixed on the scale of 10. Moving to next one. The next one we have condition monitoring techniques. So in the previous slide we have already discussed. That means there are certain amount of parameters are there, starting from the motor current, lubricating oils, thermographic analysis, pressure analysis, vibration analysis, online parameter like temperature analysis, and if required, it must go for the performance monitoring. So go for these parameters, there are certain amount of ideal condition for monitoring techniques are also adopted. So the first technique is simplicity used with the pass and fail indication of a simple scales. Then it is insensitivities to sensor locations so that the repeatability should not be considered. The third one is insensitivity to the load condition of the machines. So which should not be go for offloading or overloading the machines. The last fourth one is we have robust equipment to withstand type of maltreatments common in industrial situations. And the last one is intrinsically safe techniques in both technical sense and manner are used to implement the safety procedures in case of monitoring programs. So moving to next one. So there are the number of agencies are there. So we here in this particular session we have discussed about the different agencies who are providing large set of condition based monitoring data. So we have national and international standards are there. We have diagnostics equipment manufacturers are there. We have equipment manufacturers are there, and we have experienced operator on the similar machines are available. So they are providing large set of asset data. Moving to next one, preparing the condition based monitorings. Thank you.